Welcome to the course, A Foundation for Machine Learning and Data Science, section Introduction to Machine Learning. In this section, we will review what is machine learning, what are the differences between automation, machine learning, and statistical modeling, though they are highly related fields, what are different types of machine learning available, more specifically, what are the differences between supervised and unsupervised learning, what are the differences between ML algorithms and ML models. We will also get a snapshot of various stages involved in ML projects. Also, I'll tell you what is covered in this course and what is not. What is machine learning? The science of teaching machines how to learn by themselves. Machines capture data from the environments and feed them to the ML models. Machines can do high-frequency repetitive tasks with high accuracy without getting bored. ML brings together the fields of mathematics, statistics, computer science, and much more. Automation, machine learning, and statistical modeling are highly related fields. Let's see the differences between them. Automation, a technique used to build systems that works independently with little or no human assistant, and it is rules-driven and does not evolve. Examples: automobile assembly lines, consumer electronics, fastags on toll gates, arms and ammunitions, industrial machinery. Machine learning, an algorithm that does evolve by learning from past data and changing its decisions or performance. Examples: regression algorithms, classification algorithms, clustering algorithms, and reinforcement learning algorithms. Statistical modeling, formalization of relationships between variables in the form of math equations. Examples: census data, public health data, social media data. The key to remember here is that automation is rules-driven, does only the repetitive tasks, and does not evolve. Machine learning is algorithm-driven, learns from the data, and does evolve. The only relation between automation and ML is that ML enables better automation. Machine learning algorithms in general, algorithms that learn rules from labeled examples. A set of labeled examples used for learning is called training data. A set of labeled examples used for testing is called test data. The learned rules should be able to generalize, to correctly predict or recognize new examples not in the training set. I'll explain this with an example. Assume that we have a data set like this. Here, each column represents a feature. The last column has the names of each row of data, without which we will not know what the rest of the features represent. Hence, we can say that each row is labeled with a name. This is called labeled data. If we remove the last column, then this data set becomes unlabeled. For now, let's keep it. The n-1 columns are called the columns or features or attributes or predictor variables or independent variables. And the last column is called the target or outcome or dependent variables which we are trying to predict based on the independent variables. The rows in the table are called the examples, samples, observations, or instances. I will be using these words interchangeably throughout this course. When developing ML models, we will split the dataset into two parts, such as the training dataset using which we will train the ML model, and the test dataset using which we will test the ML model to see how it performs based on the training. Let's say this dataset does not have the last column name. Then there is nothing to predict because the dataset is unlabeled. However, we can find out the underlying patterns in the dataset. For example, let's plot the data in the graph like this. We can see that there are 5 distinct groups. However, we may not know what these groups represent: cheetah, tiger, bear, chicken, boar, we have no idea. This type of grouping is called clustering. The type of ML that deals with labeled data is called supervised learning. The type of ML that deals with unlabeled data is called unsupervised learning. Let's see what are the different types of machine learning available. Supervised learning, a learning problem that involves a target variable and a set of predictor variables. Examples: diabetes detection, predict whether a person is diabetic or non-diabetic based on features such as age, height, weight, BMI, glucose level, etc. House price prediction, predict the price of a house based on a feature such as location, number of bedrooms, number of bathrooms, total square feet, etc. Customer churn prediction, predict whether a customer will leave or stay with us based on age, income, buying pattern, frequency of purchase, amount of purchase, number of complaints made, feedback, etc. Unsupervised learning, a learning problem that does not have any target variables to predict. Rather, it is used for clustering or segmenting populations in different groups. Examples: clustering, customer segmentation, dimensionality reduction, anomaly detection. Semi-supervised learning, a learning problem that involves a small portion of labeled examples and a large number of unlabeled examples. Examples: image and speech analysis, web content classification, test document classification. Reinforcement learning, a learning problem that does not have the properties of any of the above mentioned three types. Here the machine is exposed to an environment where it trains itself continually using trial and error, and it learns from experience and tries to capture the best possible knowledge to make accurate predictions. Examples: ChatGPT, self-driving cars, and robotics. More closely, let's see the differences between supervised learning and unsupervised learning and ML algorithms and ML models. Supervised learning deals with labeled data and knows what the correct outputs should be like. Unsupervised learning deals with unlabeled data and approaches problems with little or no idea of what the outputs should look like. In supervised learning, we have the idea that there is a relationship between the input and the output. In unsupervised learning, we drive the structure by clustering the data based on relationship among variables. However, we do not necessarily know the effect of the variables. Categories of problems in supervised learning. Regression, we try to predict results within a continuous output. Classification, we try to predict results in a discrete output. Time series, we try to predict results from the data collected over a period. Categories of problems in unsupervised learning. Clustering, we try to find patterns and grouping from unlabeled data, and the algorithm do not transform or change the data. Non-clustering, we try to find the association between data from unlabeled data, and the algorithm do transform or change the data. Example: identify similar voices in a party. Supervised algorithms are less difficult. Unsupervised algorithms are more difficult. ML algorithms versus ML models. ML algorithms are procedures that are implemented in code and run on data. ML models are outputs generated by algorithms that run on data. In simple terms, models is equal to algorithms plus data. ML algorithms learn from data just like humans learn from experiences. ML models contain the learnings from data by an ML algorithm. ML algorithms can be represented by pseudocodes. ML models represent what was learned by an ML algorithm. Here are the various stages of an ML project. There are 11 stages, and they are: Stage 1, business understanding; Stage 2, data understanding, in which we will dive deep into exploratory data analysis; Stage 3, research, in which we will dive deep into list of selected algorithms to build the ML models and list of model evaluation metrics. Stage 4, data pre-processing, in which we will dive deep into data cleaning, feature selection, feature engineering, dimensionality reduction, split datasets for train and test, data transforms, handling imbalanced classes. Stage 5, model development. Stage 6, model training, that is initial model training and selection. Stage 7, model refinement. Stage 8, model evaluation. Stage 9, final model selection, that is final model selection and training. Stage 10, model validation. Stage 11, model deployment. What is covered in this course? A black box ML concepts, a high-level understanding of the 11 stages involved in developing and implementing ML projects, Python for machine learning and data science, how to use NumPy for numerical computing, vectorization, broadcasting, data transformation, and so on, how to use pandas for data analysis and data manipulation, a solid foundation for machine learning and data science including Jupyter Notebook Markdown codes, linear algebra, statistics, probability theory, object-oriented programming, and important libraries used in ML projects. What is not covered in this course? The underlying theoretical concepts of mathematics of ML, low-level details of how a particular ML component works. With this, I'll conclude this video and I'll see you in my next video, Anaconda, an overview and installation.